Today we're going to talk about the struggles of Roy Halladay. This is a little bit more in depth from the visualization on the Major League Baseball pitch FX system that I talked about last week in class. In class we looked at the broader uses of the tool, and now I'm going to focus on a really specific problem. What is wrong with Roy Halladay? He's a pitcher for the Philadelphia Phillies. He's almost certainly a Hall of Fame pitcher at this point in his career. He's won the Cy Young award in both leagues. He's pitched a perfect game. He pitched a no-hitter in the playoffs. He was really good, and through 2 starts this year, he has not been lived up to expectations. So we're going to look at if the data can tell us anything using this tool. Before we get there, I will point out that I'm using all content within this presentation under the fair use guidelines within the U.S. copyright law. In particular, the Major League Baseball videos fall within fair use. These are the links for all content we're going to see. First off, at a high level, last year, Roy Halladay was an effective pitcher. We see the batter here is quite off balance. The pitch, he's not coming close to hitting it. This year, however, it's a different story. This pitch right here is extremely hittable, and Justin Upton, the batter, hit a home run to right field to really sink Halladay. Let's go take a look at what the data says. So this is last year. I'm using the Brooks Baseball tool, Pitch FX. If you just Google Pitch FX, this is them. Go to the tool. I've selected a date and a game. So I'm actually looking at Roy Halladay last year, so August 4th, 2012, against the Arizona Diamondbacks. And I've done this because last year Justin Upton played for the Diamondbacks. Let me select that I only want to see Justin Upton. And I'm actually just interested in Justin Upton's 7th inning fly out. So first off, we see pitch speed is not phenomenally fast, and that's, I think, a hallmark of a really good pitcher is that the speeds don't have to be really fast. Let me pull up the game from the other day to sort of highlight the differences. So this is from April 3rd, 2013. We are looking against first inning Justin Upton home run. So we can see the pitch speed here actually is a little faster than last year. So last year he got Upton to hit out weekly. This year, even though his pitch speeds are pretty good, Upton hit a home run. Let's take a look at the release points. They look pretty similar. Maybe this year, let's see, it's just above 6 feet last year. This year, just below 6 feet. Maybe that's a problem. We can see here in the tool, the light blue cyan is the hit or the home run that Upton got. Last year, this dark blue is the out that Upton hit into. If we look at the strike zone plots, so where in the strike zone you throw the ball matters a lot in terms of how effective a pitcher you're going to be. This is this year. These 2 ones here in the middle of the plate, Upton fouled them off. That's this maroon color. Maybe that means he wasn't expecting them at the speed that how they threw them, but that's a really bad location to be throwing the ball. You'll see last year, there are none that are in the middle of the strike zone. Let's look again at last year. We'll compare. That's the same plot. That also is the same plot. Let's take a look at horizontal movement versus speed. Okay. So last year, so we have horizontal movement on the x-axis, speed on the y-axis. Last year, the low ball was thrown at a really low speed at Upton, weakly grounded out. You have a swinging strike down here, really slow. The fast pitches were a little on the inside. The slow pitches were a little on the outside. This year, what we're mostly seeing is up. And even though the speed is pretty good, we're not. This is a bad outcome. So I'm not sure we see anything terribly meaningful there. Let's take a look at the speed versus the vertical movement. So what we've got about 10 inches of vertical movement, almost no vertical movement on the pitch that Upton didn't hit very well. Fair amount of vertical movement in this case. So that's around, what, between 5 and 11. You're looking at about 5 and 8, not nearly. He's got a lot more vertical movement this year. Let's take a look at the vertical versus the horizontal movement. So last year, here's the 0-0 point, dead center in the graph. Upton, Halladay had a little movement to the right. This is from the catcher's perspective. So a little movement to the right, a little movement to the left, not terribly much vertical movement between 4 inches down and 7, 8, 9 inches up. This year, though, we're seeing not a lot of right movement, a lot of left movement, and a lot of upward movement. Let's look at the spin. In the spin, we've got about 250 degrees last year. The one that Upton couldn't handle was around 100 degrees of spin. We're seeing a lot more spin, it looks like here. Well, actually, that may just be a red herring. It looks pretty similar. Let's look at the spin versus the rotation. Last year, you got, what, 200 and something degrees on those with between 1,400 and 2,000 RPMs. This year, there's less variance. It all seems to be kind of lined up right here in this axis. The one I think is most telling here is this horizontal versus vertical movement. Analysts on TV seem to think that Halladay's problems are related to speed and that he's lost speed. That may be that he's lost some speed and that it's causing something, but it looks to me like the problem, just from this small sample here, is that Halladay used to have, so look at this, you're like -10 and plus, you got a little box here, from -10 to about -2, and from 5 up to 12. That's this year. And last year, you just didn't see that much inward movement. You saw a lot more. You saw more outward movement. This might be the problem, because maybe what's going on is that last year these pitches were staying in the strike zone, and the movement was they would look hittable, and then they would shift outside to a right-handed hitter. So they look hittable, but then they turn out not to be. Versus now, these pitches are driving up and in. This pitch is going to look like it's going to hit you. There's no way you're going to swing at a pitch this far inside and this far up. So what very well might be happening is last year, Halladay would throw a pitch, and the batter would swing at it and miss it, low and outside maybe. And this year, the batter is ducking because the pitch is coming high and inside, and so he's not swinging. Getting batters to swing at bad pitches is fundamentally one of the most important things in baseball. If you can't get batters to swing at bad pitches, you have to throw them good pitches. And that's exactly what happened here. So let's look again at this Halladay pitch here. This is low, which is good. It's towards the middle of the plate, which is bad, but the problem is it's low, and it's still in the strike zone. He had to throw Upton this pitch because Upton is either able to cream everything else he's throwing because everything's in the strike zone and in the middle of the strike zone, or he's just waiting for this pitch because he knows that he doesn't have to hit anything else that Halladay throws. So let's actually take a look at the videos here. This is last year.
Got him.
That was pretty good. This is this year.
Fly ball, well hit right center.
All of that's within fair use, by the way, for all of you MLB investigators watching this video. So what we just saw right there was pitches that were in similar locations, and the guy last year is just completely unable to handle it. And this year, players are creaming the ball. Halladay's had one of the weirdest opening starts this year. He struck out 9 batters in just over 3 innings. So he got 10 outs, and 9 of them were strikeouts, but he also gave up several hits and a couple of home runs, including the one from Upton that we saw there. I think we've at least identified something that if I were the pitching coach of the Philadelphia Phillies, I'd be looking into, which is why is Upton's release point changed? And then why does the pitch appear to be drifting in and up versus last year? Both of these could be the cause. They could also be a symptom of something else going wrong. I mean, this right here, this release point's a pretty big difference. It's dropped, looks like about 6 inches. And then again from the inward motion of the pitch, it does appear that the horizontal and vertical movement has changed significantly since last year. So what can we learn from a big data visualization perspective? Tools that allow people to dig into specifics are really helpful. Like in this case, maybe we've solved Halladay's problem, or maybe we've isolated it. Or if we're an opposing team's hitting instructor, maybe we've nailed what he's doing wrong and what pitches to look for. This is extremely powerful. This isn't big data visualization where you look at it and you go, that's cool, what can I do with it? This is the way that I think big data visualization should go. Don't worry about the flashy graphics, worry about being able to answer questions. So I can start with Roy Halladay this year. So I'm looking at Philadelphia Phillies versus New York Mets. This is Halladay's second game. And I can take a look at, well, his pitch speed on TV, they say his pitch speed's down. That's not that slow. 92 miles an hour, 93 miles an hour. Yeah, he's not hitting 100, but I don't know that he needs to. And if I compare that to a game last year, so 8/4/2012. I don't know that we're going to see much variation. In fact, I know that we're not because I've already looked at the data. Let's see, Arizona Diamondbacks, Philadelphia Phillies. Yeah, so we're not really seeing, there's a little bit higher speeds, but he only hit 90, he hit 94 and he came close to it a few times. He crossed 93 4 times last year, in this game last year, and this year he didn't hit 93. Okay, so he's lost a little velocity. But we're only talking about 4 pitches out of 90 pitches. That doesn't seem to be that he's hitting that speed. He's not relying on the speed. This release point's dropping. That's a big difference. That's 6 inches there of difference in location. That might explain why the balls are sitting in the middle of the plate. But like I said, what you can see here from a visualization perspective is the ability to start with the big picture and dive in, and we can keep filtering and we can try to answer questions.